video we are going to show
Hello everyone, in this video we are going to show you our work and results on the business process modeling project for crisis management. We were asked to provide a process-oriented information system in order to help the prefect to coordinate all the actors in a scenario of flooding of the city of Blois. So we were provided with a scenario. We were provided also of all the tables of the database, and also we were asked to do some work. So basically we started by building our database. So we created all the CSV files as you can see here, and we managed to import all of it here in the MySQL workbench. So we have our database, and also we generated a UML diagram as we can see here, and that helped us a lot to understand the crisis management and how we are going, how things are connected together, and what we need to do in order to carry on our work. So as we can see here, table services, it's in the center, it's the main table, and we can see that almost every other table is connected to services, and also it is connected to itself as we can see here. After that, we managed to build a CSV file with 10 scenarios, and that in order to help us build a PetriNet with Prom. And so we did. As we can see here, we imported this file, we converted it to XES file log, and with the help of alpha algorithm, we managed to build a PetriNet, this PetriNet here. And what we can see about this PetriNet, and what we can learn, is that 10 scenarios are not sufficient enough. Also, we managed to visualize our social network with handover, and here this is the result. After that, we build our model in Bizagi in order to do our simulations. So basically we can see here that we have all our actors and all the actions done by each of them. For example, here we can see that everything starts with a prefect that notifies mayors, and then at the same time, parallel, they launch the second roll call, but mayors are not alerting the population, and so on until the end, after the administrative support, which is the end point. We can have a quick look at all our model. How does it look? Here we can see our resources. Basically it's all our actors, and we can validate, and we can see here that it is validated without any error. After that, we can go on with our simulations. So basically here, what we can do, we can play with some values in order to have some results, and based on the results we have, we can see what we can change in order to have better results later on. So here we can see that we can change the max arrival count. We set it to 120 times. Basically, what does that mean? It means that the max arrival count, we can have up to 120 incidents. Also here in the properties, we can see that, okay, the name is scenario 1, is version 1, the duration is 90 days per instance, it is based on minutes and in euro. If we go to time analysis, here we can verify what we said before, that we have 124 instances, and that it takes 5 days for another instance to come. Here we can change the time. That means that how many days or how much time does the prefect need in order to notify the mayors or to launch a second roll call, and how much time does the mayor need to alert the population. As you can see, we have different values here based on what do you think it is the best values to put, but we will change them later in order to have some better results. So basically here we can see that for every action, here we can change the time value of each action that needs. In the resources analysis, we can modify everything. We can modify time again, how much time and how much waiting time here we can put. We can see the resources. Here we say that this action will be done by the prefect, and we need one of the prefect in order to do the action. Here we can see exactly the same, that this action is done by mayor, and also we need one mayor. Here, as again, we can change, and we will play with these values in order to see if with many mayors, more mayors or one, you have better results. Here in resources, we can see that our default value, it is 20. That means that we have 20 mayors we can use. We have 20 ARS, Aglopolis, and one prefect. And costs are fixed to 0 for now. Of course, you can change that also. So after that, if we do a process validation, and here we can start a simulation, we can see that out of 120 simulations, it will be 120 simulations. And here we can see how our model works. Here we can see the differences until the end, that normally it will be 120 also. Okay, we don't need our results yet. So basically that was our first simulation. Let's see the results. So here the only thing we can see is how many days, not how many days, how many instances are done by each actor. If we close and we do, for example, resource analysis simulation, and we run it, here we can see that out of 120 instances, we said that we will have 120, but each instance after 5 days, we can see that the maximum number will be 19, and this 19 here it's 18 are done in parallel. Accommodation plan, that means that it is working. But what we can see here, and we can understand that out of 19 instances that were completed, only 7 were completed. And with that, we can see that in this graph here, this is yellow, and this is prefect, is using the more resources. And we can verify that here in the results. Indeed, the 60% of the resources are used by the prefect, 88% from mayors, almost 8% from ARS, and so on and so on. Here we can have analytical analysis. These are our actors. What type of work did they had to do, and actions? How many instances were completed? How many instances were started? Which is the minimum time for instances? What is the maximum time? And based on that, the interesting part here is that although we fixed our costs to 0, here we have some total fixed costs.